Today we're going to talk about solving equations, absolute value equations, and graphing them also. Just as a reminder, absolute value is the distance from zero. We have to remember this when we're solving absolute value equations. So to solve the absolute value equation for these, the absolute value of 4, or the absolute value of x equals 4. Recall, if we have the absolute value of 4, that's equal to 4, and the absolute value of negative 4 is also equal to 4. So when solving the absolute value of x equal to 4, we say that x can be 4 or negative 4, because if we put either of these two in, we get, if we put 4 in for the absolute value, we get 4. If we put negative 4 in for the absolute value, we also get positive 4. Just like solving regular linear equations, we do the same thing. We need the y, so we have the absolute value of y minus 7 is equal to 3. We want the absolute value of y by itself, so we're going to add 7 to both sides. So you always want to have your absolute value or any of your variable chunks, is what I like to call them, variable chunks, isolated. So we're adding 7 to both sides. We have the absolute value of y is equal to 10. Now similar to here, that means that y can be equal to 10 or negative 10. If we put 10 in for y, we get positive 10. If we put negative 10 in for y, we get positive 10. Now let's think about this one. The absolute value of v is equal to negative 7. Remember, absolute value is distance from 0, so the distance from 0 of something is negative. There's no solution. There's no solution because we can't have a distance equal to a negative number. This one we have the absolute value of y minus 7 is equal to negative 4. Just because there's a negative 4 here doesn't mean it's no solution. We have to get the absolute value by itself first. So let's add 7 to both sides, and now we have the absolute value of y is equal to 3. This is solvable, so we have y is equal to 3 or negative 3. Now we want to solve the absolute value of equation 2v minus 4 is equal to 6. If we had the absolute value of x is equal to 6, we would say that x was equal to 6 or negative 6. So what we're saying is what's in the absolute value is equal to positive 6, or what's in the absolute value is equal to negative 6. We're going to do the same thing over here, but this time what's in the absolute value is 2v minus 4, so that's equal to 6, or 2v minus 4 is equal to negative 6. You don't want to take plus or minus your final answer. You want to take what's in the absolute value is equal to 6 or what's in the absolute value is equal to negative 6. So we add 4 to both sides for the first equation, and we have 2v equals 10. Divide by 2, and we have v equals 5. Or for the second equation, we add 4 to both sides, and we get 2v equals negative 2. Divide both sides by 2, and we have v equals negative 1. So our solutions are v equals 5 or v equals negative 1. Let's check our answer quick. Checking is the same thing as we were doing earlier, so we're going to take the absolute value of 2 times 5 minus 4. That's equal to the absolute value of 10 minus 4, which is the absolute value of 6, which is 6. So v equals 5 checked out. Let's try the absolute value of 2 times negative 1 minus 4. That's the absolute value of negative 2 minus 4, which is the absolute value of negative 6, which is 6. So both of those answers checked out. So again, it's not that when you solve the first side and take plus or minus, you have to solve the inside equal to 6 and then the inside equal to negative 6. Same thing here. We want the inside equal to our positive value and our negative value. Now, if we have the absolute value of A equals the absolute value of B, we say that A can be negative A or positive A. I'm going to do it twice because we're actually going to have to use it twice. And we have negative A and positive A. And then we also say that B could be negative B or positive B. So there's 4 different things we can do. We can have a negative equal to a negative, a positive equal to a negative equal to a positive, or a positive equal to a positive. Notice, if we multiply this whole equation by negative 1, we get a positive equal to a positive. Negative times negative is positive, negative times negative is positive. If we multiply this whole equation by negative 1, it switches signs. So even though it looks like there would be 4 cases, there's still only 2 answers, because the negative equal negative is the same as positive equal positive, and if there's one negative, you can write it either way. So for this one, we can do 2w plus 3, that's our positive, equals the other positive, w minus 4. So positive equals positive. We just write it exactly like it is, only without absolute value signs. Or 2w plus 3 equals negative of the whole inside of the second one. Now notice, I don't start solving when there's absolute value signs. I start solving after I split it up. So now we can subtract 3 from both sides, and we have 2w equals w minus 7, and subtract w from both sides, and we get w equals negative 7. Here we have to distribute our negatives, so we have 2w plus 3 equals negative w plus 4, distributing our negative. So now we subtract 3 from both sides, and we have 2w equals negative w plus 1. Add w to both sides, and we have 3w equals 1. Divide both sides by 3, and we get w equals 1/3. Plug both of your answers back into check. So we would have the absolute value of 2 times negative 7 plus 3. That's 2 times negative 7, that's negative 14. Plus 3 would be the absolute value of negative 11, which is 11. And then we have the absolute value of negative 7 minus 4, which is the absolute value of negative 11, which is 11. Make sure you check in the original so that to make sure both sides are equal. The second side, we're going to have the absolute value of 2 times 1/3 plus 3. So that's 2/3, the absolute value of 2/3 plus 9/3, remember your common denominator, equals the absolute value of 11/3, which is 11/3. And then we have the absolute value of 1/3 minus 4, which again is the absolute value of, this one's going to be negative 11/3 because 4 is 12/3, which is positive 11/3. Notice if you didn't check in your original equation, you would have thought that positive 11/3 equals negative 11/3, and that didn't check out. So our answers for this one, but because we checked in the original, it does check out. Our answers are w equals 1/3 and W equals -7. Same thing happens with absolute value inequalities. We want the absolute value of x bigger than 4. So the distance from 0 is bigger than 4. So we have x is bigger than 4, or x is less than -4. So what you want to do is write it exactly like it is without the absolute value sign, and then we want the negative also, and we flip the inequality. Same thing happens here. We're going to add 7 to both sides because we want the absolute value by itself. So then we get the absolute value of y is less than or equal to 10. And now we write it exactly as is. Y is less than or equal to 10. This one is actually and I'll show you why in a second. And y is bigger than or equal to -10. So if we write this on a number line, the first one, the absolute value of 4, or absolute value of x is bigger than 4, we have a -4 here, and we have 4 here, and we go this way, and we go this way. For the absolute value of y is less than or equal to 10, we have -10 here, and we have +10 here, and we have, it goes this way to here. It only goes here because if it's more than -10, it's the distance from 0 is going to be more than 10. So it's only these two. So it's an and statement. Typically, we graph them out quick. If it splits, we're going to put an or here. If it doesn't split, if it goes together, we're going to write it sandwiched. So -10 is less than or equal to y is less than or equal to 10. So see, the y is between -10 and 10. So let's look at these. The absolute value of a number, the distance from 0, is bigger than -7. All distances are bigger than negative numbers, so it's all real numbers. So some of these you can just look at and solve. What about this one? The distance is less than -7. There's no way that a distance can be less than a negative number, so this one is no solution. So let's try this one. Again, we need the absolute value by itself, so we're going to have subtract 3 from both sides. We have 2v minus 4 in absolute values is less than 2. And now we're going to solve. So we're going to take the positive side, 2v minus 4 is less than 2. And then we're going to take the negative side, 2v minus 4 is bigger than -2. We switched the sign and made the right side negative. Solve each side separately, so we're going to add 4 to both sides. 2v is less than 6, divide by 2. V is less than 3. This one we're going to add 4 to both sides. And we have 2v is greater than 2, so v divide by 2, and we get v is bigger than 1. Let's quickly draw that. So we have v is bigger than 1 and less than 3. So it's in between 1 and 3. So that means we're going to write it as 1 is less than v is less than 3. It's shaded in the middle, so that's why v is in the middle there. Graphing absolute value, we're going to use a combination of what we know about graphing lines and plotting points. So remember y-intercept and point-slope form? Mostly point-slope form. Remember, it was y minus y1 equals the slope x minus x1. And x1, y1 was a point on the graph. When we're solving absolute values, we're going to look for something similar to this, only instead of parentheses here, it's going to be absolute value. So here it's y, let's write it as y minus 0 equals 3 times the absolute value of x minus 0, because there's nothing there. So 0, 0 is going to be a point on our graph. This is actually going to be our vertex point. So we're going to plot 0, 0, and then we're going to just plot some other points. So we're going to try, let's try x equal to 1, y equals 3 times the absolute value of 1, which is 3. So one of our points is 1, 3. And then let's try x equals negative 1. And we have y equals 3 times the absolute value of negative 1. So that's y equals 3 times 1, which is 3. So another point is negative 1, 3. And recall from when we did this back in section 3.2, I believe it was, absolute value did look like a V. And notice also, here's our 3. If we count 1, 2, 3, and over 1, this 3 out here is similar to what our slope is for lines. But we have a positive and a negative, just like we do for all the other answers. So let's try this. So if we add 2 to both sides, we have y plus 2 equals 3 times the absolute value of x minus 0. So if we were looking at point slope form, that would be 0, negative 2 would be a point on the graph. So 0, negative 2 is a point on our graph, and now we can do x equals 1 again, and x equals negative 1. Solving for x equals 1, we have y equals 3 times the absolute value of 1 minus 2. So that's 3 minus 2, which is 1. So one of our points is 1, 1. And solving for x equals negative 1, y equals 3 times the absolute value of negative 1 minus 2. Again, that's 3 minus 2, which is equal to 1. So another point is negative 1, 1. And there's our V again. Y equals the absolute value of x minus 4 to graph. There's nothing with the 0, and we have negative 4. So now we have a point on our graph is positive 4, because remember it's minus is the opposite, 0. So positive 4, 0. So now instead of using 1 and 1, we used 1 and 1 on this one, because the vertex was here and we went 1 up and 1 down from the vertex. So this one, we're going to use x equals 3 and x equals 5. 1 up and 1 down from the x values of the vertex. X equals 3 and x equals 5. So y equals the absolute value of 3 minus 4, which is the absolute value of negative 1, which is positive 1. So one of our points is 3, 1. And then our other point is y equals the absolute value of 5 minus 4, which is the absolute value of 1, which is 1. So our other point is 5, 1. So 5, 1, and 3, 1, and we have our V again. Notice, thinking about it, if we have the absolute value of x minus 4 equals, say, 2, our x equals 2 line is right here. And it crosses here at x equals positive 2 and x equals positive, is that positive? Yeah, positive 2 and 1, 2, and x equals positive 2 and x equals positive 6. So if we were to solve this equation, we would get x equals positive 2 and x equals positive 6. You can solve it by graphing or you can solve it algebraically. It's better to solve algebraically because sometimes it's hard to read off of a graph. So let's look back. We just graphed y equals the absolute value of x minus 4. That was this graph. So we're going to graph, that was, here was our first point, here was our second, here was our third. And now we're going to, this is a strict inequality, so we're going to use a dotted line. And then we have to figure out where to shade. So again, let's try our 0, 0 point. So 0 is bigger than the absolute value of 0 minus 4. 0 is bigger than the absolute value of negative 4. This is our question. 0 is bigger than positive 4. That's false. Here's 0, 0, so we're going to shade opposite of where that is. So we're going to shade inside our absolute value instead. That's it for today. See you tomorrow.